drives, and those are considered to be the pumps for forced air. Many times this is what breaks in most duct systems, and there are ones where you have direct drive. I would say direct drive is when you have the motor attached directly through a coupling with the inducer fan. Same thing that we have in oil burners. So if we look here, it's the same thing. The motor and the inducer squirrel cage fan is inside, and it's connected through a coupling. You see this sometimes in ducts, but a lot of other times you see also the belt drive. Belt drive makes it easier. Alex makes it easier to replace the motor. There's a tensioner at some point where you can release the tensioner or loosen your motor so you can take the belt out and do the maintenance. Taking out the squirrel cage from the casing usually is challenging, and a lot of people who do sheet metal use ducts also complain about removing the pump. So this is a better way to do it. And again, there's also a limit for the tension. If you tighten the belt too much, the tensioner too much, probably you will, after a while, ruin the bearing. Probably Remy can tell us about that.
Yeah.
If it's too tight, yeah, after a while you will bend the shaft, or you will ruin your bearings in the motor. So make sure it's not too tight and it's not too loose. Generally speaking, in cars, from what I know, and also for ACs, it should be able to push it with your finger while it's off by half an inch. And some instrument, they have actually required tension. You use a belt tensioner where you push against the belt and tell you how many inches of pressure is in there. Again, it's a direct drive motor. So talking about the supply. So now we thought about the size of the duct, and I think I showed you the hand here. We showed the calculating ruler for the slide. Yeah, slide. Just for the slide as well. This is how you calculate the duct size. Now we'll talk about duct system. So the plenum system is basically an air handle unit that pumps air. It's very short, right on the air handle unit, and you get branches coming out of it directly. Extended plenum is when you have a long plenum or long house that goes along the house and you get branches right out of it. Reducing plenum system, long plenum again, however, it reduces in size as we go further from the air handle unit. What is the purpose of reducing the plenum?
Maintain pressure.
Maintain pressure, so you have the same air pressure in the entire plenum. The perimeter loop is very, very similar to the piping system, the dual pipe system, where you have one air duct goes around the house and supply all the registers with air, and you have another duct that takes all the hot air. So plenum system is suited for jobs where the rooms, outlets are very close to the unit. So let's say you have a house that's not that big, you're not going that far from the air handling unit, you can just put a plenum on top of the air handling unit and have branches going to each room. Usually supply diffusers are located inside the walls. It works better with fossil fuel because you're required to have a lot of temperature. Fossil fuel is one of the only ways that you can supply temperature up to 130 degrees Fahrenheit. Heat pumps will not give you this much heat. Probably you'll be around 90 or 100. How hot do you want the air coming out of the register? If you want the room to be at 75, you want to be at least at 90, 95, 85. You don't want to be very hot because that will affect the furniture or your comfort when a lot of hot air is pumping into the room. So this is the plenum system, air handling unit. This one is hanging in the attic, and this is the plenum. It's very small. The air is being pushed over here, and you have trunks coming out of it, actually branches coming out of it, and you can supply that to every room. This is very suitable for a cooling unit. I don't know if it's going to be good for heating because, again, this is going through the ceiling, and also if it's gas, probably you can put a gas furnace in the attic, but I don't think you can put an oil burner in the attic. So for oil, you're not not supposed to do that. But for furnace, probably it's gas. I had that before. I've seen that before, where a gas furnace is put in the attic and you can pump air to the bottom from the top of the ceiling. The problem with that for heating, you need a lot of throw, which you need a lot of pressure to push the air down and to mix it. Otherwise, the hot air will be in the top portion of the room. Like half the room will be hot and the bottom will be very cold and very uncomfortable. So that's the planner. And this is going to be our return coming from major return. So extended planner, it can be applied to a long structure. If you have a very long structure where you have the boiler on one side and you have at least 100-yard long house, you take the planner all the way to the furthest point, which maintains the pressure and you maintain the temperature in the entire trunk. They call it also a trunk duct system. Ducts called branches, complete condition terminal units. And this is what it looks like. So if we have a picture here, yeah, this is our planner. So our heating unit, so it goes both ways, extended all the way to the end. And that's going to be uniform temperature and uniform pressure. And from that, you supply little branches or flexible duct. I'm not a big fan of flexible duct if it's longer than 6 feet, because again, there's a lot of losses due to friction, because it has a lot of ridges.
Is that also the code in mass or something?
Yeah, so of course, something has to be certain length, and you cannot exceed that. And that length is based on actually the same noise and losses. You lose a lot of energy pushing the air through. So this is reasonably not that long, but if it's too long, you might want to put some actual GI or galvanized steel duct. So reduced planner, that was the extended planner. So it just gets long, but it's the same size. Reducing planner, the trunk keeps reducing as we go further, and that will maintain pressure because, again, we said pressure equal the velocity square times the area. So as you reduce the area, you can maintain, the velocity will increase to maintain constant pressure. You don't need to know that, but this is the theory. So as I go further, the pressure will decrease. As I decrease the pressure, I need to reduce the pipe. How come we don't do that with water?
Because you put a pump in?
Yeah, what else? What is the difference between water and air? Compressible. So compressibility, as we go further, air will be less compressible and you might compress in the beginning and it spreads out and you'll lose pressure. With water, you'll have the pressure has a different equation and it's not compressible, so whatever comes in from this place and goes out without any kind of compressibility. So it has the advantage of saving material and keeping the same pressure from one end to another. And as we reduce, we save more material. This is very significant if you work with sheet metal. Who will say something about sheet metal? That's actually a dying art. A lot of people are not doing sheet metal anymore.
Yeah.
And it's very, very high demand. I know there's a job here in STC HVAC where they're looking for somebody who has a sheet metal license. Yeah, go ahead.
So yeah, most of the sheet metal, they just buy pre-made.
Yeah.
Because most of the sheet metal we get is all pre-made. We only sell sheets.
Yeah.
They 4x8 sheets a couple times a week, but
You can see why a company wants somebody who can do their own sheet because it's less expensive. And if you order pre-made sheet metal or fittings, they will have to be shipped, which will increase the cost because it's done in a factory. So it's very costly, and if you want to repair, you have to order something, it might not fit. So to have somebody who have the skill to be able to work with sheet metal and do all these fittings, that'll be very convenient. That will increase your possibility to be in HVAC. A lot of people do not want to do sheet metal because it's labor intensive. Yeah?
Did you get that here?
No. There are some technical schools that offer sheet metal. I have to have certain amount of hours working with sheet metal. I know in Putnam, they do a lot of sheet metal. You spend a lot of hours. Can you get your license from Putnam?
Well,
As sheet metal?
no.
But you spend a lot of hours doing sheet metal there.
Yeah, but you gotta make a separate shop for that.
So that's another thing. And what else? it doesn't seem very attractive for people because once you work on it for a long time, you find it's very difficult to work with. You'll be hanging on a ladder all the time, or bending and doing some line. So most people just shy away from that. But if that's something you enjoy, you should get certified, and I assure you, you'll do a lot of job in that field. So this is the extended planner. So there is a lot of finesse in how to connect those and how to reduce the size. And there's some calculation involved, so you can calculate and do the drawing beforehand. A lot of geometry involved, and to have that work that doesn't look ugly or flimsy or leaking, it's also an art. You might have worked in a lot of stores. I've seen a lot of hanging sheet metal or duct that work that look really flimsy and doesn't look professional at all. So this is something it's really interesting. Do you know why they have this ridges here, the X ridges? Yeah.
To support or to strengthen up the, that was to strengthen up the,
Structure?
yeah.
I think from my perception, I haven't asked any special, but I think it's like also for damping provision, to reduce the vibration, and also to give it some kind of structural
Yeah.
strength. Because if you have this ridge like flat, it will wobble, it becomes a drum. But if you put some ridges on it, it will reduce the possibility of it to wobble and to make any noise when you extract and contract. And this is the reducing planning. So it's very suited for concrete. This is the perimeter now. So the perimeter goes around the structure. It's very good for concrete floor, colder climate. It's one of the least expensive ways to put duct system. I've seen it also in crawl space, because you go in the bottom and you just go around the room, put it on the top, or put it in the top, anything in the top or the bottom. Warm air is a whole loop, so the same thing as the hot water. You keep the warm loop, warm air in one circle, and you pull from it using dampers. Same thing with the intake or return register. Keeps the slab more even temperature if you have slab. Provide the same pressure at all outlets, but we uniform pressure. Same floor plan, and now we have our heating unit, and we have our perimeter loop system. This is the perimeter loop, so you have 4 legs to the coming all the supply. This is all supply, and you want to have uniform pressure and uniform temperature, and you have dampers in each one of those sections. So if you notice here, you can also zone using dampers. Where do you think you should put the dampers? And why? So they say it's better to put the dampers as close to the main unit as possible. Why? If you put the damper here, air is still going to push around here, and air is compressible, and that will lead you to have a lot of vibration. So you'll have a lot of noise and a lot of losses coming to this leg for no reason. So if you want to have a damper, you might want to put a damper here, and a damper here, if you want to cut off this section. So put the dampers as close as possible to the unit. Also, you might have a partially open or a fully open damper, and those can be controlled remotely through automatic dampers. You can put that here. What I've seen, again, from some economical or cheap installation, that there are no dampers. If you want to close this register, you just go with a lever and close it. But that is very noisy. The air will push through here and cause a lot of noise. It's the same thing when you go into your car and turn the AC all the way high, and you close all the vents and only one vent open. So you're going to be shooting air really strongly, and it will make a lot of noise from the other dampers. So first thing you want to do when you want to calculate the CFM, and that's something I want you to do for the project, once you do the cooling, I want you to give me the CFM, just to practice using this equation. It's the B3 of the roof divided by 108, which is a constant, and delta T. Delta T is the supply temperature coming from the plenum, from the air handling unit, and the room temperature. I'll write this down. How do I know the temperature register? You're gonna go there and take a thermometer. There are some clip-on thermometers that you can clip in, and it will give you the temperature coming out. And you go to the return over there, and you clip it on the thermometer, and see what is the temperature difference between the room and the incoming air. The BTU is for the room, and 108 is constant, and this will tell you how much CFM you should provide. So air velocity should be between 700 and 800 and 900 BPM. I'm gonna look at one of those, there's one of these to that system. Consider frictional losses of 0.08 to 0.1 water gauge, and if you use any of these rulers, it should be good to stay within frictional losses. The reason between frictional losses is you want to reduce the pressure that's being lost, which will be compensated for by increasing the inducer fan speed, which will cause you to lose a lot of energy. Flow rate is air times velocity. That's the amount of flow rate, and CFM is the flow rate. And aspect ratio, that's if you are using rectangular duct, you don't want to be more than 3 to 1. So if one leg is 6, the other one should be 2, and so on. For round and squares, you go by the total area. I'm gonna pass these around so you can look at them and see how they work based on the velocity. They're very easy to use, and you can get some from the supply house. You're not gonna go into the math calculating those will make things a little bit more convenient, unless you have some ugly shaped or really large duct. So that work must meet the local code in terms of material, distance, and support. Again, duct is not really that heavy unless it's really large, and it requires to have the right support. And a lot of times, some of the main problems with duct. Can you name some problems with duct? Besides noise, dust, fungus, mildew, moisture. Some duct has to be cleaned every few years or annually, depending on the temperature and how do you maintain the humidity. Huh? Yeah. And if it's too big, it might be an entry point. So that's another issue. And also insulation, if it deteriorates, you can release some air from the ductwork. For years, galvanized steel sheet metal was used exclusively. It's still the main dominant ductwork. People like it because they're strong, they're mechanically sound. They also have some issues, but they are very rugged. There are other stuff, but they haven't proven to be the most dominant so far. And galvanized steel is very good because it can handle temperature, high temperature and low temperature without any problems. The other options now, people are still coming with new ideas to make it cheaper. Aluminum is another option. There's also aluminum fiber that is like, it's foam board with aluminum on both sides where you can easily cut them and put them together. But again, they do not withstand high temperature, so they are good for cooling, but they are not good for heating. Fiberglass ductwork, this is condensed fiberglass put together with some kind of aluminum foil on the outside. Spiral middle duct, those basically they look like, you'll start off with, I'll put over there. They're very actually interesting. If you look in the duct we have in the shop, or on the shop, it's a spiral, and it's really easy to put together. So you get a roll of aluminum with some edge on the side. So what you do is just you take it and you connect this to the bottom, and you end up with a tube. It looks like that. Finishing the top. And you can control the diameter. They have different rolls. You can roll them around and consistent. You can go to big or too slow. And if you become really good at it, there are ways you can make it mechanical, smaller and bigger. And again, you go to the job with a bundle of this big, and you make duct out of it. Again, it's okay, it's acceptable, but all these seams are areas where you can have leaks, and also where you can have deterioration. And it also reduces the velocity of air. So if you have a smooth surface, that means the air is gonna run smoother and there will no areas of losing pressure. If you have more ridges, then you'll have more resistance to the flow. Flexible ducts, you buy them, they're basically aluminum foil, plastic aluminum foil with some support. They look like those little umbrellas you have for a car, shades with a twist, they have a wire inside. These are the cheapest way of duct I've seen so far. And you have to be aware that it should be resistive to the temperature, otherwise over time the plastic will deteriorate. So gauge, when we look at galvanized steel, they give you the gauge. The gauge is the thickness of the metal, and that thickness has to do with the size of the duct, so it does not collapse on each other, it does not wobble and can hold shape. Many pieces of material would need to be stacked together to make one. We need to understand what is the gauge size mean. Thicker gauge means look, it's a thicker sheet metal and can support more weight. Metal duct can be round, square, or rectangular, and a person with a sheet metal certificate, they know what the gauges and how much of a space can you go without having support, because the gauge can support itself. And they have a lot of general rules for cutting and angles and pitch. So that's what the sheet metal is about. That's what the certificate will give you. The art of making sheet metal looks nice and having good craftsmanship, that's up to you. And that's why people charge more than other. Fiberglass, either easy, you can cut it with a knife, lightweight, that is normally 1 inch thick, aluminum foil backing, special knife to cut it. We can put it in place with duct tape and aluminum tape. Did anybody ever try to connect the dryer hose to the outside? It's so annoying because it's very spirally and you connect one point and the other side comes out. So it's a struggle because again it's very flimsy, it's very cheap. You can buy the whole pipe for like $5. And if you do a mistake and you crimp it, you'll sell that luck because you have to get another one. So it's very, very cheap enough aluminum and made of something that looks like that spiral cut. And if you bend it too much, it will disengage and you have to put some tape on it, and it does not look very, very pleasant. And the function also is not good. And another thing that you have to consider is the insulation to the outside. If it leaks a lot of air, or absorb a lot of air, it's an issue. Does anybody have one of those stand-in ACs? Stand-in unit where you have a tube coming to the window?
I heard those suck.
Yeah, why?
They don't like the water or whatever, like the humid moist or something like.
Okay, yeah, that's good because they suck because there's no way to drain the water.
Yeah.
And most people are going to, the water in there, if you plug it, the water will be evaporated back into the room to cool the condenser, which does not make sense to make it less efficient. If you want to make these units efficient, you have to drain it to the outside, because we know that all the BTUs are going to be used to condense the water, latent heat, before they add heat to your house. So the first thing you want to do, either drain the water into a bucket or to the hose to the outside. Second thing, which I found very ridiculous, is the connection from that unit to the window is not insulated. You touch that pipe, it's so hot. So you're rejecting heat, but most of the heat is not going to the outside. It's actually coming back to the room. So if you want to make it really work fine, you have to insulate that pipe, make sure there's no leaks, and drain it outside. Which becomes a very annoying process if you don't have, if you have a window, you don't need that. Might as well just put a window, you see everything to the outside, instead of standing. So they consume a lot of energy because of these two reasons. Otherwise, they work very well. Spiral, duct metal, they are more used in live systems. Again, with short distances. It comes in rolls of flat, narrow metals. Runs can be made on the job, fairly easy. And can be located within occupied space for more than contemporary look. If you look over there, they look very nice. It's not square, it's not spirally. And most duct work is square, this one round, and they're easy made. Flexible duct, these are the ones that come with the support, with the wire, and you have to make sure that you don't overexpand them, put them in the right distance. They come to up to 24 inches diameter. Some have reinforced aluminum foil backing, keep it in place. Some come with vinyl foil backing or insulation on it. They keep duct runs as short as possible. We said 6 to 10 feet is maximum. You don't want more than that. Has more friction losses inside than metal duct, of course, because if you take a look inside, you'll see the spiral, and you have foil running through it. So these ridges are very resistive to the velocity. It's not going to run as good as smooth surface, but they're really cheap and fast to install. We have them all the way here, but to our advantage, the unit is over here, very close by, and you can hear it. You can hear the air actually coming. You want to also have them stretched as tight as possible. Why is that?
So they don't sag.
Yeah, so they're not sag, and also if you look at this area here, you want to be as stretched out as possible instead of it being rigid. So, and that's going to be a challenge because you're going to put it in one end and you're going to pull on it and it will dislocate, and the membrane will be in tension. When things are in tension, like under tension, they are easily breakable. Anything will fall on it, it will be already in tension, and the possibility of breaking it is very, very large. So this is an example of flexible duct. This is supply, the return, and this is where you want to put the floor register. This is my return line over here. Okay. Duct air movement. Branch ducts are fastened in the main branch by takeoff fitting. Fittings are very important, and if you go to Home Depot or Lowe's, you'll find a lot of fittings specified to each connection, so you don't have to try to put duct tape all over the place. And by the way, duct tape also comes in different temperatures. Don't use duct tape, regular duct tape on heating pipes, because it gets hot up to 120, 130, and some duct tapes cannot withstand that. Air movement duct has inertia, meaning it wants to move in a straight line. So if you swirl it, if you give it a lot of resistance, it will swirl and create a lot of vortices, and that will slow down the air from moving. Turning vane will improve the airflow around corners. So what are turning vanes? Kind of like a fitting for the pipe, 45 degree, 90 degrees. You want to stick with around 45 or 90, and those will smooth out the turn. And it's a fitting also with some kind of streams in it, so the air does not have a lot of friction and does not swirl a lot, and you do not encounter some kind of a shock wave with the air goes too fast, and you have a big vortex inside, and it will shock your flow. Main duct, these are reducers. This is all the fitting. If you notice, the reducing takeoff kind of smooth out the flow and will provide you with more flow coming in here. Because if you think of this panel and this small pipe, probably it will be harder for you to push the air through. No matter how much pressure you put in there, it will be a little bit harder. So make sure you always have some kind of reducer here or takeoff fitting. Okay, I'll stop here and I'll finish this presentation on Wednesday. Most of this information actually is in the book, and it's also adapted from the Principles of Aviation book, in chapter 21 or so. So if you want more details, probably you'll find it.